So let's take a look at number 1. Simplify the following expressions. So here's A, and what they give you is vector AB plus vector BC. Now, we know from Chastel's relations that when the end point of your first vector added to the second vector whose start point are the same, then you can just cross them out and rewrite this as vector AC. So this would be something that looks like this. You have AB, and then you have, so this would be point A, this would be point B, and this would be point C. So this would be then vector BC. And finally, what happens if you follow this path over here is that your end result looks as if you just went from A to C. That's why this added to that looks like AC. Now, 1b, they are telling you mn vector minus rn vector plus rp vector. Now, here you're going to use the property of opposite vectors. We know that to turn this vector here into a positive vector so that there's no more negative here, you can just rewrite this, but with its start and end points reversed. So you have mn, that stays the same, and then you write plus, and then what happens here is instead of having rn, you have nr. So this is properties of opposite vectors. Plus, and then you have rp. Now, by Chastel's relations, you have the start and end point here that are the same, and the start and end point in the second two vectors are the same. So you can cross them out like this, and your final answer is going to be mp vector. And finally, for C, there are a few things you can do. I'm not even going to use Chastel's, although you could use it. I'm going to show you a way faster trick using commutativity of vectors. So PS minus 2PS plus PS. Now what I'm going to do is commute the middle term here, the negative 2PS, with the last term PS, and that gives me PS plus PS. So by commuting them, what I did is I switched their positions, minus 2PS. And this is just 2PS minus 2, oops, minus 2PS. And this is really simple. You've got something subtracting, and you subtract it, take it all away from itself. So what you're left with is the 0 vector, right? Because when you add or subtract vectors, you're supposed to get a vector. So I can't just write 0, I have to write the 0 vector.